Hello, and welcome to this short video showing you how to integrate the GJD range of IP security devices into your RTI project. GJD make a very nice range of PoE-powered IP security products. These consist of the Detect range of motion sensors, the Hysteresis range of infrared and visible light illuminators, and the IPA, which is an I/O controller that can integrate multiple inputs and relay outputs into your project. So let's take a look at how we integrate this into your RTI project. The first thing you need to do is to bring the driver into your project. Now there's just a single driver that covers the entire range of Detect, Hysteresis and IP devices, and when you bring it into your project, you then configure it with the number of devices of each of the types that you are going to support. So here we have a project that is configured with just a single Detect device, and here you can see the properties for configuring that device. We will look at those in a moment. If, say, we had a project with 3 Detect devices and 1 Hysteresis, then what's happened, we've got configuration parameters now for each of the individual devices. So let's now look at the configuration for the Detect first off. There are a number of parameters here you need to configure. The name is an installer editable field, and the reason for having this is it just makes it easier to refer to RTI system variables and functions with the right name for your detector. So let's say this was a front door motion sensor. You need to configure the IP address and username and password to access the device. In addition, there are certain parameters that you need to consider in order to tell the Detect what sort of events to send out. There's no configuration required on the Detect device. All the configuration is done automatically by the RTI driver. So there are just a few parameters you need to fill in: high and low temperature alerts and hysteresis value. So what this means is if the temperature exceeds 35 and raises an alarm, then these two actually drop 5 degrees below that before it will go into the non-alarm state. This is just to prevent multiple triggers if the temperature is hovering around that 35 degrees mark. In addition, for the Detect, there's a low light level value and the light level in lux, which the low light alarm is triggered, and then a configuration that says when motion sensor is activated, whether it's always activated or only when the light level is below that value or above that value. After having configured the Detect, we can now look at what variables and functions are available for that. So with the Detect here, you can see we've pulled in the name, we've got front door here and all the system variables that are available. So we've got PIR detection, low light, tamper, temperature value, high and low temperature flags. We've got light level and the current state of the 2 relay outputs on the device. In terms of the driver commands that are available, there are 2 relay outputs on the unit, and we can open, close and toggle the state of those. We can also put the unit into a walk test mode, and if there has been a tamper alarm, we can actually reset it. So we now also need to look at the events that the driver generates for the Detect device. So here we can see the events for the Detect device. We've got the PIR being activated, the low light level being detected, the high and low temperature alarms, and the tamper. And we can simply add the event So if we want something to happen when the PIR is activated, we can trigger that system macro. Now we've provided a virtual panel interface that is useful just for testing the functionality of the detect. And this is already wired up to the various system variables, indicating the status of PIR detection, low light, temperature alert, and so on, and also being able to control the relay inputs. Now let's have a look at the Clarius. Again, it's configured in a very similar way. There's the IP address, username and password. We can give it a friendly name, and again high and low temperature limits, hysteresis and low light level. It's very similar to the detect. System variable wise, again it is very similar. There's only one relay output on the Clarius, but also there is one digital input. Looking at the system functions, we've got the control of the relay output, open, close and toggle, similar to the detect. We then have a number of functions for controlling the state of the illuminator. So we can put the LED illuminator into a standard mode, switching it on and off, setting the power. We can put it onto a boost mode with a timeout measured in seconds, or into energy save. Or if we want to, we can actually put it into a strobe state. So let's now look at the events that are generated for the Clarius. Here we see the Clarius events, and again here we've got low light, high, low temperature alarms, but we've also got events for when the digital input goes into a high state and a low state, and also the tamper state. So let's say we have a digital input and something wired to the digital input. We want to generate an event when that goes low. Simply select that event and select the macro that we want. If we have a look at our virtual test panel for our Clarius device, you can see we brought in the system variables for low light detection, tamper, temperature, state of the input, and output, temperature display, light level, and also control of the relay output and all of the functions for control of the illumination. This panel should be fully working in this example, so you are ready to go and evaluate with it. Finally, let's go and look at the configuration of the IPA. Now this is a very flexible product that has 4 digital inputs, an analog input, and several relay outputs. Each digital input, as well as detecting high and low states, can also detect frequency of the incoming signal. So in the configuration we have values for high and low limits on that input frequency. So that is true for 4 digital inputs. Then we also have an analog input, and we have high and low values for that together with a hysteresis value. There's also IP address, username and password, the typical configuration that we need. Now remember, there's no configuration required on the IPA. The driver takes all the parameters and then configures the IPA to generate all the necessary events, making your life very simple. Looking at the state of the variables, it's very much as you would expect. Variables for temperature, high and low, the current state of the outputs, the current state of the inputs, and whether there has been a frequency alert on each of those inputs. and likewise current value for the analog input and high and low alerts. In terms of system functions for the IPA, there is control of the 3 relay outputs, open, close and toggle, and the ability to reset the tamper. There are quite a few events the IPA generates, and you can see them all listed here. We've got the high-low temperature alarms, and then for each of the digital inputs, as we have mentioned, you get events when those signals go high and low, or there is a frequency coming in, then it will detect whether or not there has been a frequency alert according to the parameters we have configured earlier. But this is replicated for all the 4 inputs, and then for the analog input we've got high and low alarms. Then taking a final look at the virtual panel, here you can see for the IPA we have the system variables visualized here and control of the 3 relay outputs. Thank you very much for watching. If you have any further questions, contact information for GJD and Janus are now on your screen.